Okay. So yeah, cool guys. I wanted to talk with all of you for 5 minutes. So yeah, what all I wanted to discuss was, first of all, I want you to give an idea just now. Class has just started now, and we'll start the lecture at 8 o'clock only. I just wanted to talk to all of you for 5 minutes, right? So that is why I started the class a little bit earlier. Okay. So first of all, what I want to say is, how does the module course actually look like going forward? Okay. So I think all of us know that we have been going at a slightly slower pace. And when I was ill, I couldn't take up 2 to 3 classes at that point of time. So we are little behind lagging, right? So I have come up with a plan, okay, a course of action using which we can complete the module on time without compromising the quality of the content, as well as giving sufficient classes for problem solving, as well as giving you guys later self practice time. Okay. So how the course will be flowing on from now is something that I wanted to discuss. So today is Friday, right? So Friday from 8 to 10, okay, just follow me along. Friday 8 to 10, we are starting off with sorting one. We are starting with sorting one, right? Now you will ask me, hey, why are we not discussing about time and space complexity? Some questions were left, right? So if you read here, I have just designed this today. So let's see how all you feel this is. So I have kept sorting today so that you all get one day time to read about the time and space complexity articles that I shared. Okay. So I want you all to read those articles and first of all, absorb the concepts before I go on and discuss some more questions in the class. So that is why today I will not be discussing questions on time and space complexity. Today we will be starting with sorting one. Okay, so Friday is sorting one. Okay. Now, one thing is that on Saturday and Sunday also we will be having classes, right? But I have taken into consideration that people have office and everything. So we don't, engage in classes in the morning, right? So Saturday, that is tomorrow, okay? From 8 p.m. till 11 p.m. we will have a class where we will again do sorting 2, and we will discuss some problems from time and space complexity. So my expectation will be till tomorrow night, you at least read the articles that I have shared with you and get a basic understanding of time and space complexity. So that tomorrow when I discuss it, you at least know something about time and space complexity and you are able to follow along, right? अब जब 8 to 11 कर दिया तो naturally doubt session cut. Okay, cool. Then Sunday again 8 to 11 p.m. Sunday everybody has a holiday and 8 to 11 p.m. rakha hai, so anybody won't be having a problem, right? So Sunday from 8 to 11 p.m. we will be starting with recursion 1, right? And in these 3 hours we will complete the basics of recursion, right? Then Monday we will meet from 8 to 11 p.m. once again. Monday no doubt session, right? And we will again spend 3 hours learning about recursion. That is recursion 2. So on Sunday and Monday, 3-hour classes covering recursion entirely. Okay. Then on Tuesday, 8 to 10 is your standard class. We will be covering merge sort. Wednesday, again standard 8 to 10, we will be covering quick sort. Thursday, now comes the interesting part. Thursday from 8 to 10, or I am thinking we will do it 8 to 11, right? This also works fine. We will again indulge in a full problem solving session. We will solve a variety of questions on sorting, right? So Thursday, we are delving into full problem solving. And Friday also, we can keep it from 8 to 11 if you guys want, more miscellaneous problem solving, right? So I am making sure that we get 2 full-fledged problem solving sessions, okay? We get sufficient time to cover all the concepts, and we are no way, compromising the quality of the lectures. So this is the plan that I have stated. Okay. So do you feel this is fine? I mean, I have created this after a lot of thinking only, so that koi bhi day zyada heavy nahi ho, no day is light also, and we are spreading everything properly. Okay. Switch case we will do. Okay. Switch case we will do. Okay. And see guys, so Thursday and Friday, this is full problem solving. And after Friday, Saturday, Sunday, Monday, Tuesday, 4 days you will get for your self-study and practice. Okay, Saturday, Sunday, Monday, Tuesday. Approximately 4 days after this, you will get self-study and self-practice time. And after this, you can expect the module test to be somewhere around 31st. Okay, that's a tentative date. Okay, but I'll announce the final dates later. Okay. So yes, ultimately what I want is till Wednesday, the theory part will be covered. After this, 2 days entirely for problem solving. And after this, if you want, we can again have more problem solving. But after Friday, your self-study time will start. Okay. So that is one important thing that I wanted to tell you. And in this, we can make few amendments. But yeah, this is the basic flow that we are going to follow, right? So your job will be, first of all, the articles that I shared with you all. Okay, the articles that I shared you all, just please read all these articles of time and space complexity so that tomorrow night, when we are discussing problems of time and space complexity, everyone knows the fundamental basics. Okay, that is why. No, when you have session from 8 to 11, right? It's mostly on problem solving will happen. And a couple of sessions 8 to 11 we have kept because, you know, we are lagging in the theory portion a little bit. So I wanted more time. Okay. No, Sunday morning, I have kept it in the night so that nobody has a problem, right? Otherwise, someone will say in the morning we have office work, something like this. So let's keep the standard timing, right? Okay, cool, guys. So that is what I wanted to, you know, ask all of you guys and convey this information. So yeah, hopefully the plan looks good. And yes, the reading material links I have shared on Discord. Okay, cool. I will share this entire course plan also with you guys on Discord. Okay, so that all of you have access to what we will be doing when. Okay, cool. So as per plan, we can have 2 sessions also. I think that makes it a little bit hectic for you all. We got this feedback. So that is why I have kept it in the simplest fashion that I could think of without, you know, making things hectic. What about tomorrow class, 8 p.m. to 11 p.m. Okay, cool. Test format will be, it will be conveyed for all of you, right? Okay. Yes, after Friday, if you want, we can take more problem solving sessions, right? Idea is after Wednesday, it is all about problem solving and revision, right? Okay, cool, guys. So without any further ado, right, we will get started. I have started the recording. And guys, today's topic is highly unrelated, right? So even if you didn't understand time on space complexity, please pay attention. Sorting is a very, very interesting topic and it is a brand new topic from scratch. Okay. So if you follow, you will definitely understand and you will enjoy this topic a lot. Okay. So let's get started, right? Let's get started. Any other questions I will take towards the end of the class? Otherwise, we don't get time, right? So let's not waste the lecture time. I will take your question towards the end, all the other questions, right? Okay. So we will be starting with the concept of sorting. Now, what exactly does sorting mean? Can anybody help me? What does sorting mean, right? It's a basic term, right? It's nowhere related to coding. What is sorting? What is sorting? Sorting is basically when you arrange your data elements in some pattern, right? What does sorting actually mean? Sorting means you are arranging your data in some pattern, or you are arranging your elements in some pattern. Okay. So I have been given certain data elements, right? You have certain data elements. And when I sort that data, I basically arrange the data elements according to some pattern or according to some rule, right? So whenever we talk of sorting, right, the most or the two important sorting, or, you know, the two important ways in which we sort something is basically ascending order and descending order, right? So what is sorting? You want to arrange your data. Boss, तुम्हारे पास कुछ numbers है. You have certain data and you want to arrange it in some pattern. Now, what pattern? The two commonly used patterns that we follow in sorting is you can arrange your data in ascending order, okay? Or you can arrange your data in descending order. These are the most two commonly used patterns in sorting, right? Either you will be arranging your data in ascending or you will be arranging your data in descending order. Now, what is ascending and what is descending? When you arrange data starting from the smallest till the biggest, right? Starting from the smallest, you go to the biggest. That is ascending order. And what is descending order? Starting from the biggest, you go to the smallest. That is descending order. Okay. So we will be discussing about ascending and descending order. Okay. Now, when I say, boss, sorting actually means arranging the data in some pattern. Okay. So can you tell me, boss, think of it like I'm just drawing some random, patterns, right? So if I say this is the data elements, right? I'm just giving you a very vague example. If this is a data elements, these are my data elements. And if I ask you, boss, can you arrange the data elements in some pattern, maybe in ascending or in descending or some other pattern, then do you guys agree there will have to be a rule via which you can decide which element should come first, which element should come second, which element should come third? Boss, you have your data elements, right? And I ask you, can you arrange your data elements in some pattern? तुम मेरे से क्या पूछोगे? Okay, I can arrange them in some pattern, but tell me what is the rule that I have to follow? How will I determine which element will come before? मेरे को कैसे पता चलेगा whether this square should come first, this triangle should come first, or this circle should come first, right? How will I arrange? There has to be some rule using which I will be able to decide, right? So what I say is, whenever we talk of sorting, right? We will be generally talking of an array of integers, right? So we are basically talking about sorting an array of integers. We are most interested in integer data types, right? And when I say that, boss, I have to sort the array in ascending order, you know what rule I will follow? Acha guys, one thing, I can sort integers. Okay, I can arrange the integers in ascending order because I can compare integers. See, I have this sense now, ki 8 and 6. If somebody gives me 8 and 6, I have this knowledge ki boss, 8 is greater than 6. So definitely 8 should come after 6. So I know ki this is a rule. Ki if any element is greater than an element, then it should come after that element. Are you getting what I'm trying to say? See, we are able to sort integers because we can compare integers. Okay, we are able to sort it in ascending order because we are able to compare integers. I know this rule ki boss, if 8 is greater than 6, right? 8 is greater than 6. So definitely 8 should come after 6. Okay. No, Mukul, yesterday's topic is not yet complete. But if you were there in the earlier 5-10 minutes, right? I told that I will start with sorting today, and tomorrow we will discuss some questions of time and space complexity so that you get time to go through the articles that I have shared and get a basic understanding. Okay? Cool. So what I am saying is, when I say sort the data elements or sort the integers in ascending order, right? Now, why can I sort an array of integers? Because you can compare integers. You establish this rule. Ki boss, this number 8 is greater than 6. This number 8 is greater than 6. So definitely, if I want to sort in ascending order, 8 should be coming after 6. So basically, given any two data elements, I need to understand whether this will come after this or this will come before this. Are you getting what I'm trying to say? Whenever you are sorting your data elements now, you need to have a rule. Ki boss, if I take any two elements now, I need to understand whether A will come before B or B will come before A. You need to understand this. Now, when you have this rule laid out clearly, you can start sorting your array, or you can start sorting your data types. Okay, whatever data that you have. Okay, sorting is basically arranging your data elements in certain pattern. And most commonly, when we talk about sorting, we talk sorting of array of integers. We are going to sort integers. And why are we able to sort integers? Because we can compare integers. I can compare. If I give you two numbers, 7 and 5, you know that 5 should occur before 7 because 7 is greater than 5. Okay. Similarly, we can also sort an array of characters. Okay, we can also sort array of characters. Why? Because you can also compare characters. Can anybody tell me how you can compare characters? If I ask you B versus D, yes, correct. Something like this. Because characters have their ASCII codes, right? So you can compare characters as well. So long story short, what I have told you guys is, sorting is you are arranging your data in some pattern. Okay. And what is this pattern? There will have to be a rule. There will have to be certain rule via which you will be able to understand what elements should come in what order. Boss, आप एक pattern में arrange कर रहे हो ना, but you need to have a rule. Okay, you need to have a rule. Ki given any two elements, okay, given any two elements, how do I decide which one should come first and which one should come later? Okay, so the rule will help us to arrange the data in some pattern. Yes, you can have your own rules. We will see. Okay, the most common patterns that we talk about is ascending and descending order. Ascending is basically arranging things starting from the smallest till the biggest, and descending is starting from the biggest till the smallest. Okay. And what did I tell you? Let's say I want to sort an array of integers in ascending order. So we can sort an array of integers in ascending or descending order. Why? Because given any two integers, you know the pattern. Ki boss, if 7 is greater than 5, then 7 needs to come after 5. So because we are able to compare integers, we are able to sort them in ascending or descending order. Okay. See, if I tell you very, very logically, right? If I ask you very logical question, ki boss, can you sort this array of integers in ascending order? Or can you sort these numbers in ascending order? Then, even if you don't know anything about the code now, you will tell me, hey Adarsh, you know what? 5 will come at the starting, then 7, then 8, then 10. Yes? Now, how are you able to decide that 5 will come at the first? Somehow, somebody has programmed in your mind that you will compare 5 with 10, 5 with 7, 5 with 8, and you see that 5 is the smallest. So you place 5 at the starting. Okay, inherently, without I having to tell you. So why are you able to sort data? You are able to sort data because you are able to do comparisons and you know where data come. Okay, you are able to understand that boss, this data element should come before these 3 data points. Okay, cool. So now, see, you will be requiring sorting in a large number of problems, right? It is a very important technique to have, right? Now the question comes, how do I sort an array of integers? Okay. Now we will start with the sorting techniques. Is everyone clear till whatever I have told till now? Sorting karna aata nahi hum log ko, but I have told you how we can perform sorting, what is sorting, and there has to be certain rule. And following that rule only, you will be able to arrange your data elements in some pattern. Okay. And we are able to, sort an array of characters or sort an array of integers in ascending or descending order because we are able to compare two integers. And I know the relationship between two integers. And that is what helps me to set the rule. Okay. Cool. Now, can we use arrays.sort? For sure, Pranchu, but I'll tell you when you might not be able to, right? So now the question is that, boss, given an array of integers, okay, you have an array of integers. अच्छा, अभी तक अगर नहीं भी समझ में आया ना, forget it. Long story short, what you need to understand is sorting is arranging the data in some pattern. And today we will understand how to sort integers or how to sort characters or any data type in ascending or descending order. Okay? Cool. What is the application of sorting? Okay. So if you see roll calls, let me give you a very practical example of sorting, right? If you see the roll calls that teacher take in your school, how are the names written down? The names are written down in alphabetical order. They are sorted in ascending order. So in real life and in coding also, there will be many cases where you might want to sort your data. Correct? Amazon and Flipkart. You try to sort the products, right? You sort it by price, you sort it by rating and all these things. So there are a lot of practical applications of sorting for sure, right? So now I will ask you, we'll start up with a question and we'll try to understand how to sort. Okay. So my question is, I want to sort an array of integers. Okay. So first of all, we will learn a technique of sorting. The first technique, which is bubble sort. Okay. This is the first sorting technique. This is a technique which will help me to sort an array. Okay. Or sort some data elements, right? Okay. So I have an array of integers, right? I have an array of integers. And now I want everyone to pay complete attention because now we will understand how to sort an array. Very, very important thing. Okay. So let's say you have an array of integers 8, 5, 7, 3, 2. Okay. And I want to sort this integer or sort this array of integers in ascending order. So how will my array look like after sorting in ascending order? 2, 3, 5, 7, 8. Does everyone agree? Everyone? I think this doesn't require any coding knowledge, right? So my job is to sort this array in ascending order. Whenever I talk of sorting, we will be talking of sorting in ascending order. You can try in descending order yourselves. It will be similar only. Okay. Now, let us now try to understand how do I sort this array in ascending order. Okay. So let's get started with the algorithm and then you will be able to understand better. Okay. Now we will analyze this entire bubble sort algorithm in detail. How does sorting actually work? Okay. So for better illustration of this algorithm, right, I am drawing the array like this. Okay. From top to bottom, I am drawing it like this. 8, 5, 7, 3, 2. These are my array elements. Okay. So let me start with how bubble sort actually works. Okay. So what will happen is, let's say you have a pointer j. You have a pointer j or I, whatever, over here, right? Now what you will do is, I start comparing adjacent elements. ध्यान से सुनो मेरे बात को. You will start comparing adjacent elements. Let us say that the name of this array is ARR. So you know what I will compare? I will compare ARR of j with ARR of j plus 1. ध्यान से सुनो मेरे बात को. You will start comparing adjacent elements. That is, I will compare ARR of j with ARR of j plus 1. So I compare 8 with 5. What do you see? You see that 8 is greater than 5. Okay. Now, can you tell me, guys, if 8 is greater than 5, then definitely 8 should come after 5. Do you all agree? I want to sort in ascending order. And if 8 is greater than 5, then 8 should be coming after 5 and not before 5. So what I will do? I say, please take I. Arey, J se kar lete, ek hi baat hai. It is a variable, right? A simple variable. Okay. So I compare ARR of j with ARR of j plus 1. So I compare 8 with 5 and I see that boss, 8 is greater than 5. And 8 is greater than 5 now. So definitely 8 should come after 5. So what I will do? I will swap these two elements. I will swap these two elements. So what will happen? Now 5 will come here, 8 will come here, and 7, 3, 2 are as it is, nothing. Okay. Now what I will do? After swapping, I will move my j forward. So now my j comes here. Okay. So I first of all compared 8 and 5. 8 was greater, so I did a swap. Okay. Now j moves forward. Next, what I will do? Again, I will compare adjacent elements. That is ARR of j with ARR of j plus 1. Again, I compare adjacent elements, right? So what will happen? 8 is greater than 7. So what should I do, guys? Can you help me? Boss, 8 7 se bada hai and 8 is occurring before 7. That is not done, right? 8 should come after 7 because it is greater than 7. So again, I will perform a swapping. Again, I will perform a swapping. So how does my array now look? 5, 7, 8, 3, 2. And my j will move further. So now my j is here. Okay. Again, I compare adjacent elements. So I compare ARR of j with ARR of j plus 1. ध्यान से देखो, guys. First, I compared 8 with 5. 8 was greater, so I swapped. Then I compared 8 with 7. Okay. 8 was greater, so I swapped 7 and 8. Now I am comparing 8 with 3. Now I am comparing 8 with 3. What should I do, guys? 8 is greater than 3, right? So again, I should swap. Again, I should swap, right? So how does it look? 5, 7, 3 comes here, 8 goes here, and 2 is here, right? Now 8 and 3 I have swapped. Now what will I compare? Obviously, j has moved forward now. So again, I will compare ARR of j with ARR of j plus 1. That is, I compare 8 with 2. And I see that 8 is greater than 2. So what will I do? Again, I perform a swapping. Again, I perform a swapping. So how does my array look like? Okay. Okay. Now see, guys, I have compared j with j plus 1. Now j comes here. Okay. Now, is there any other element left to compare? Boss, you have compared 8 with 2 and 8 came here. Now, can you compare any other elements? No. So I stop here. I stop here. I stop here. Now I tell you, boss, one iteration or one pass of bubble sort has happened. Okay. At this stage, I tell you, one pass of bubble sort has been performed. And if you see very carefully what has happened in one pass of bubble sort, Look at your entire array. What was the heaviest element? The heaviest element is 8. Okay. And this heaviest element has come down and settled at its correct position. Do you all agree that this is the correct location for 8 in the sorted array? Yes. So in one pass of bubble sort, what has happened? The heaviest element 8 comes down and settles at its correct position. One pass of bubble sort has been performed. Okay. Now, why do I call this algorithm as bubble sort? Okay. So I give this example every time in every batch, right? So, my teacher who first taught me computer in class 11, right? So he gave me a very good analogy and I always remember via that analogy. Okay. Think of it like you have a pond. Okay. You have a pond and you throw a piece of stone in the pond. What happens? The stone is heavy, right? So the heavy stone goes and settles at the bottom of the pond and the lighter bubbles will rise to the top. Do you agree? जब पानी में पत्थर फेंकते हो क्या होता है? The stone goes and settles at the bottom and bubbles will rise up in the water. So what has happened, guys? In one pass of bubble sort, the heaviest element goes and settles down at the bottom like a stone and all the lighter elements have come to the top. See, the heaviest element goes and settles at the bottom and the lighter elements are on top of the heaviest elements. So one pass of bubble sort has been performed. Okay. Now, can anybody tell me how many comparisons have you done? How many comparisons have you done in this one pass? How many comparisons? Soch ke dekho, guys. You did, this was one comparison. Okay. Then you did a second comparison. Then you did a third comparison. Then you did a fourth comparison. Okay. So can I tell that you have done 4 comparisons? And after 4 comparisons, your first pass of bubble sort was complete. Okay. So if you have n elements, do you all agree that for the first pass of bubble sort, you make n-1 comparisons? Do you all agree with me? You make n-1 comparisons. And till where is j coming? Till where is j coming? J is coming till here. See, you compare ARR of j with ARR of j plus 1. This is the last comparison that you did. So j is coming till index number n-2. Do you all agree? If you have n elements in the array, so j is coming till index number n-2 in the first pass. Okay. So my first pass of bubble sort has been done and the heaviest element has settled at the bottom. Okay. n-1 फिर से. See guys, see, I am asking you how many comparisons are you doing? First of all, you compare this 8 with 5, you do a swapping. Then you compare 8 with 7, then you compare 8 with 3, you compare 8 with 2. So how many comparisons have you done? If there are n elements, na, you are doing n-1 comparisons. सोच के देखो ना guys. 1 comparison, 2 comparison, 3 comparison, 4 comparison. n-1 comparisons. And till where will j come? J will come till index number n-2. Okay. See, this is index number n-1 and this is index number n-2. So j will come till here. You compare ARR of j with ARR of j plus 1. Okay. So the first pass is clear and at the end of the first pass, the heaviest element has gone down and settled at the bottom at its correct location. Okay. But do you think the array has been sorted entirely? No. Only the heaviest element is at its correct position. So what I will do? I will perform another pass of bubble sort. Let me draw the array. 5, 7. See, no. I won't make j go till the end, right? I compare ARR of j with j plus 1, do a swapping, job done, right? I don't want to make j go till here. No use, right? No point. Okay. So now after one pass of bubble sort, my array looks like this: 5, 7, 2, 3, 8. Okay. And I know that because one pass of bubble sort has been performed, the heaviest element is at its correct position. Do you all agree? 8 को कोई disturb नहीं करेगा. 8 is at its correct position. Correct, Arpita. Now the time has come for 7. Now I will perform the second pass of bubble sort. How do I perform? Again, I will start j from 0. Okay, I will start j from 0. So I compare ARR of j with ARR of j plus 1. I compare 5 and 7. Okay. Is 5 greater than 7? No. So do I need to do a swapping? No, I will not do a swapping. So I just simply move j forward. I simply move j forward. I don't do any swapping. I simply move J forward. So now J comes here. Again, I will compare ARR of J with ARR of J plus 1. So I compare 7 with 2. 7 is greater than 2, right? So definitely 7 should come after 2. So let me swap 7 and 2. So I will swap 7 and 2. So how does my array look like? 5, 2, 7, 3, 8. And after swapping, J moves further. So J has come here. Now I will compare 7 with 3, ARR of J with ARR of J plus 1. I compare 7 with 3. 7 is greater than 3. So I will perform a swapping. Okay. Now 5, 2, 3, 7, 8. Now, guys, I have one small question for all of you. If I move J forward and I compare 7 with 8, do you know anything will happen? Do you think क्या हुआ कुछ गड़बड़ कर दिया क्या मैं 5 7 2 3 8 करेक्ट है ना ओके गड़बड़ कर दिया ओके ठीक है let's follow with this anyways right अच्छा guys tell me I started from here first of all I compared 5 with 7 okay no change took place I moved J forward then I compare 7 with 2 7 is greater than 2 so I swap okay I move J forward next I compare 7 with 3 7 is greater so I again swap now I have one small question to you all is it any sense is it any point of comparing this 7 with 8 कभी भी 8 हिलेगा क्या यहां से 8 is already at its correct position so nobody can disturb 8 okay nobody can disturb 8 so there is no point of comparing this 7 and 8 okay so I say boss after you have swapped this 7 with 3 now the second pass of bubble sort has been performed and guys look at the end of the second pass at the end of the second pass the two heaviest elements are at its correct position okay and try to understand guys when I started the second pass my area of interest was this do you agree this was my area of interest because 8 is already at its correct position right this was my area of interest in the second pass right and what was the heaviest element in my area of interest 7 so see what has happened at the end of the second pass 7 has come down and settled at its correct position right is everyone able to follow that at the end of the second pass, the two heaviest elements are there at their correct positions? Okay. Now, if I ask you, how many comparisons did you make in the second pass? How many comparisons? You made 1, 2, and 3. So, can I say you have made n minus 2 comparisons? Can I say? Boss, this time you are not comparing till the end, right? You are just comparing till here. Okay, so you have made n minus 2 comparisons. And till where is J coming? In the first pass, J was coming till index number n minus 2. Now J is coming till index number n minus 3. Do you all agree? Yes? Important points later we will be using, right? So at how n minus 2? Okay, how n minus 2 comparisons? If I ask you, Chirag, let me take a example like this. Let's say if I give you an array like this, okay, and we are comparing adjacent elements, right? So for the first pass, I did one comparison, okay, I did second comparison, I did third comparison, right? So there were n minus 1 comparisons. Please don't take classes on Saturday and Sunday. Karthik, I don't think we have an option here, right? I've tried to make it as spread out as possible, but we'll definitely 3 hours, I think everyone can spare, right? You have the entire day for yourselves. 3 hours, I think you can give. Okay. So the first pass, you did n minus 1 comparisons. And what I am telling, in the second pass, try to understand. This space was already at, the element here is correct. So I performed one comparison and the second comparison. See? So you have reduced your comparison by 1. Okay. So in the first pass, you had n minus 1 comparison. Dekho, 1 comparison, 2 comparison, third comparison. So there are 4 elements, you did 3 comparisons. And in the second pass, you are doing only 2 comparisons. That is n minus 2, 4 minus 2. Okay. So is everyone able to follow till the end of the second pass what has happened? Yes. देखो ये बहुत intuitive algorithm है. If you pay attention and try to understand now, the code as well as the logic, everything will become clear. Everything will become clear. Okay. How do we know what is the largest element? Okay. So you are comparing now. You are comparing. See, you compared 5 with 7. 5 was lesser than 7, so you did not do anything. You move forward. Then I compared 7 with 2. the moment your j comes at the largest element now, then that element will slide down. Slide down. Dekho, 7 is greater than 2, slide down. 7 is greater than 3, slide down. So it will happen. Okay. Now, so 7 and 8 are now at their correct locations at the end of 2 passes. Now let us look at what happens in the third pass of bubble sort. What happens in the third pass of bubble sort? So you have 5, 2, 3, 7, 8. And can I tell you guys, this part of the array is already sorted? Yes, this part of the array is already sorted. So let us start our third pass. Let us start our third pass. So first of all, I compare 5 with 2. I compare ARR of j with ARR of j plus 1. 5 is greater than 2. Yes. So I will swap ARR of j with ARR of j plus 1. So let us swap. 2 comes here, 5 comes here, 3 is here. 7 and 8 are already at their correct position. Now what I will do? Now I will compare 5 with 3. Next I will compare 5 with 3. 5 is greater than 3. What I will do? Again I will swap. Again I will swap. So what happens? 2, 3, 5, 7, 8. And guys, tell me, do you need to do any more comparisons? Do you need to compare 5 with 7? No, because I already know 7 and 8 are at their correct locations. So for the third pass, you just had to do 2 comparisons. The number of comparisons again reduced by 1. Dekho. See, in the first pass, you had to do 4 comparisons. In the second pass, you had to do 3 comparisons. In the third pass, you just had to do 2 comparisons. Okay. 8 to 11, 8 to 11 night, 8 to 11 night. Okay. Okay. So now I can say, boss, after 2 comparisons, my third pass is over. And see what has happened at the end of the third pass. The 3 heaviest elements are at their correct position. Dekh lo, 5, 7, 8, right? And where is j coming? See, in the first pass, j was coming till here. In the second pass, j came 1 position above. In the third pass, j will come 1 position even above. Okay. So is everyone following what is the situation of the array at the end of the third pass? Yes. Great. Now, I will do one more pass, right? I will do one more pass. Okay. See, guys, try to understand. At the end of every one pass, one element goes at its correct position. Okay. So you might be thinking that if I perform n passes, n elements will go and settle at their correct locations and the element array will be sorted. But I am telling you one thing, right? See, now what I will do is, let us look at the fourth pass. First, let us look at the fourth pass, right? What is my array? 2, 3, 5, 7, 8. And after the 3 passes, now I know that this part of the array is sorted. Now let us see what do I do in the fourth pass. Again, I do a comparison. What I compare 2 with 3. 2 is less than 3. No change happens. Job done. Now in the fourth pass, see, do you feel that there is any point in comparing this 3 with 5? No, nah, because this part of the array is already sorted. So in the fourth pass, I just do 1 comparison. Okay. And I know that the elements are. So at the end of the fourth pass, right? The 4 heaviest elements are at their correct position. See? 4 heaviest elements are at their correct position. And I will tell you one fact. You have an array of 5 integers, right? You have an array of 5 integers. Guys, we'll discuss the timings later. Don't spam in the chat at this point of time. Okay. So you had an array of 5 integers, right? And what I am telling you, after 4 passes, 4 integers are at their correct locations. 4 integers are at their correct locations. Then does it not automatically mean the 5th number will also be at its correct location? Soch ke dekho, guys. You have an array of 5 integers and after 4 passes, I am saying that the 4 heaviest elements are at their correct locations. So obviously, automatically, the 5th number is also at its correct location, right? So can I tell you one thing? If you have an array of n elements, right? I will need n minus 1 passes of bubble sort. Dekh lo. I will need n minus 1 passes of bubble sort because in every pass, one element, the heaviest element will go at its correct location. Okay. So after n minus 1 passes, n minus 1 heaviest elements will be at their correct locations. So automatically the last element or the lightest element will also be at its correct position. Does everyone agree with me? Ki boss, bubble sort, n minus 1 passes of bubble sort you perform, your entire array of size n will get sorted. Do you all agree? Yes? सही सही बोल रहा हूं, सबको समझ आ रहा है? And guys, you understand that intuition, right? How is the heaviest element settling at its bottom, right? Because the moment J comes at the heaviest element now, then when you compare ARR of J with ARR of J plus 1 now, it will keep on sliding down, 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 down. Okay. So if you have an array of size n, you need n minus 1 passes of bubble sort. And after n minus 1 passes of bubble sort, n minus 1 heaviest elements will be at their correct locations, and naturally the last element will also be at its correct location, right? So the entire array gets sorted. Okay. Now I ask, what is intuition? Intuition is जो दिमाग में ऐसा देख के लग रहा है कि हाँ नाम को सूट कर रहा है, जो कर रहे हैं वो नाम को सूट कर रहा है, राइट? एक अंदर से फीलिंग आ जाता है, राइट? दैट इज व्हाट इज इंट्यूशन. ओके. Now instinct, right? That's a good word. Okay. Yeah, we will do problems. Don't worry. Okay. Now I ask you, boss, so is the algorithm clear to everyone? Is the algorithm clear to everyone? Algorithm. Okay, we will also see visualizations and that will also help you to understand. But now I ask you one small question. Mukul, we will see visualization and that will make it more clear, right? Or clear hoga visualization ke baad. Okay. But I ask you one very small question. Boss, what is the total number of comparisons that you have done in your entire bubble sort algorithm? What is the total number of comparisons that you have done in your entire bubble sort algorithm? Soch ke dekho, guys. I tell you one thing. In the first pass of bubble sort, how many comparisons do we do? How many comparisons? In the first pass, we do n minus 1 comparisons. Okay. In the second pass, how many comparisons do we do? Kitna karte hai? N minus 2 comparisons, right? In the third pass, we will be doing n minus 3 comparisons. And likewise, in the last pass, that is in the n minus 1th pass, how many comparisons we did? We just did one comparison. So if I ask you the total number of comparisons that we have done in bubble sort, is it not 1 plus 2 plus 3 plus 4 up till n minus 1? Do you all agree with me? Soch ke dekho, boss. In the first pass of bubble sort, you did n minus 1 comparisons. In the second pass of bubble sort, you did one comparison less. That is n minus 2 comparisons. In the third pass, you did one less comparison. So n minus 3 comparisons, right? JC, you have the... See, in this case, JC, you got the correct output at the end of third pass, right? But always it might not be possible, right? Always it might not be possible. Okay. And at the end of the fourth pass, in the fourth pass, you are doing one comparison. So if I add the number of comparisons that you are doing, does it come out to be n into n minus 1 by 2? Does everyone agree? This is the number of comparisons. Okay. So how? Okay. So can I say the number of comparisons that happens in bubble sort is n into n minus 1 by 2. Acha, how for what part? Did you not understand the summation or did you not understand this part? Which part? Formula? Okay. Formula is pretty simple. This is maths, right? This is maths. The summation of the first n minus 1 natural numbers, right? See, there is a formula that the sum of the first k natural numbers is k into k plus 1 by 2. Maths hai ye. So I want to find the sum of the first n minus 1 natural numbers. So I will substitute k is equal to n minus 1 and you will get this expression. Okay. Okay. See, again, let me talk, right? What is happening in bubble sort? See, try to understand. Again, see, in the first pass, what are you doing? You compare 8 with 5, do a swap. Compare 8 with 7, do a swap. Compare 8 with 3, do a swap. Compare 8 with 2, do a swap. How many comparisons have you done in the first pass? You have done 4 comparisons, right? So how many comparisons have I done in this first pass? Can I say I have done n minus 1 comparisons? See, what is n? N is 5, right? You have done n minus 1 comparisons, where n is the number of elements. Okay. Now come to the second. No, today class is till 10 only. Okay. Now come to the second pass, right? I again start doing comparisons. I compare 5 with 7. This is one comparison. Then I compare 7 with 2, do a swap. Compare 7 with 3, do a swap. So how many comparisons have you done in the second pass? This time you are doing one comparison less. You are not comparing this 7 with 8, right? So this is n minus 2 comparisons. 1, 2, and 3. Okay. Then in the third pass, how many comparisons are you doing? You compare 5 with 2, you do a swapping. You compare 5 with 3, you do a swapping. Okay. So you doing 2 comparisons. That is n minus 3 comparisons. And in the fourth pass, you are just doing one comparison. You compare 2 with 3, you don't have to do any changes. Okay. So in the last pass, you are just doing one comparison. So that is what I have written, right? In the first pass, you are doing n minus 1 comparisons. In the second pass, you are doing n minus 2 comparisons. In the third pass, you are doing n minus 3 comparisons. And in the n minus 1th pass, you are doing just one comparison. So what are the total number of comparisons that you are doing in your algorithm? 1 plus 2 plus 3 plus 4 till n minus 1. And that is equal to n into n minus 1 by 2. Okay. So by this, you get an idea that if somebody asks you, what is the number of comparisons in bubble sort? You will tell that the number of comparisons is n into n minus 1 by 2. So does it not give you an idea of n square work? Boss, you are doing n square comparisons. So it actually now thinks, I understand that yes, the algorithm is somewhere big O of n square. We will understand through code also, but via logical intuition, I am telling you. Okay. Now, can you tell me, guys, does every comparison lead to a swap? I have a question. Does every comparison lead to a swap? Does every comparison lead to a swap? The answer is no. So when will every comparison lead to a swap? Can you tell me? When will every comparison lead to a swap? If your array is sorted in descending order. Dekh ke dekho, guys. If your array is sorted in descending order, na, every comparison that you make, that will result in a swap. So if I ask you, what is the number of swaps? I will tell you, in the worst case, your number of swaps will be equal to the number of comparisons. And that is big O of n into n minus 1 by 2. Do you agree? See, in all the cases, the number of swaps will not be equal to the number of comparisons, right? Number of swaps is less than equal to the number of comparisons. And when does this equality hold true? When the array is sorted in descending order. So I am telling you that the number of comparisons in bubble sort is n into n minus 1 by 2. And the number of swaps is less than equal to n into n minus 1 by 2. Okay. This gives me an idea of n square work. Okay. See, Manish, in this case, you got the array sorted at third pass, right? But how do I know that the array is sorted at the end of the third pass, right? So for safety, we are performing 4 passes. At this point of time, we are performing 4 passes for safety. Because I know that at the end of 4 passes, the 4 heaviest element will be at their correct positions. And once the 4 heaviest elements are at their correct position, automatically the lightest element is at its correct location. Okay? Are you getting an idea? यहाँ तक सब लोग follow किए हैं क्या? Has everyone followed till here? Yes. So now let us try to develop a code for bubble sort. Okay. And then we will also see the visualization through which you will be able to understand better. Okay. See, can't remember the formula. See, the sum of the first n natural numbers is n into n plus 1 by 2. You remember just that. Okay. What is the benefit of bubble sort? Okay. Guys, if somebody asks you, I'm giving you a very practical example of bubble sort. If somebody asks you, find the kth largest element. If somebody asks you, find the kth largest element of the array. How many passes of bubble sort will you perform? I will tell you, hey Adarsh, perform k passes of bubble sort. So after k passes of bubble sort, now the k heaviest element will be at their correct locations. And after that, you will just have to inspect what? If I ask you the second largest element, right? Say, if I give you a question, hey, can you find the second largest element for me? You will apply bubble sort 2 times. You will apply 2 passes of bubble sort, right? 2 passes. And then you will get the second heaviest element at ARR of n minus 2. Are you getting this problem, what I'm asking you? So if somebody asks you for the kth largest element, apply k passes of bubble sort, and then you will find the answer at ARR of n minus k. Is this making sense? Yes, because I know now that after every one pass, the heaviest element goes at the end, right? How comparison is greater than equal to swap? Okay. So Kamber, I'll answer your question like this. Look at this. You compared 5 with 7. You did a comparison, right? But did this comparison result in a swap? No. This comparison did not result in a swap. So isliye, the comparisons are always more than the swaps, right? Greater than or equal to. Okay. Cool. Now let's come. Okay. Now I'll write the algorithm, right? I'll write the algorithm. Okay. And then we will try to understand via code both the time and space complexity. And then we will try to take a visualizer. What there are duplicate elements, sab pe aunga. Okay. So first of all, tell me guys, I will ask you questions, you will answer. Okay. I have an array of size n. Okay. How many passes of bubble sort do I need? How many passes of bubble sort do I need? How many passes? N minus 1 passes. Everyone agrees? Okay. So I write a loop like this for int I equal to 0, I less than n minus 1, I plus plus. Can you tell me how many times does this loop run? How many times? I am not interested in the values of I. How many times does this loop run? See guys, I think I have been getting, strange responses. So guys, understand these two patterns. If I write something like this, for int I equal to 1, okay, I less than equal to 10, I plus plus. How many times the loop runs? The loop is running for 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Even if I write something like this, now try to understand. This also runs for 10 times only. This runs for 10 times because I will take values from 0 till 9. So there are 10 different values that I is taking. So this also runs for 10 times. So looking at this, can you tell me how many times this loop is running? अब आंसर अगर सही नहीं दिए तो बहुत मार पड़ेगी सबको. Standard pattern. This was running for 10 times. How many times this loop is running? This loop is running for n minus 1 times. Do you all agree with me? This loop runs for n minus 1 time. And what I am telling you is, every time this loop runs, I will perform 1 pass of bubble sort. So this loop runs for n minus 1 times, and this will perform n minus 1 passes of bubble sort. Are you getting what I am trying to say? जब ये loop पहली बार चलेगा, I will perform 1 pass of bubble sort. The second time the loop runs, second pass will be performed. The third time the loop runs, the third pass will be performed. So this loop runs for n minus 1 times. And so n minus 1 passes of bubble sort will be performed. Am I making sense, guys, what I'm trying to say? Am I making sense? Okay. Now, when I am inside this loop, my job is to perform bubble sort. Okay. So what were we doing, guys? Let us come back to our logic. I was starting J. See. एक मिनट देना मेरे को. कोई chat में भी कुछ मत लिखना. I'll just try to clear it out. Rahul is asking n minus 2. How n minus 1? Rahul, I will take values till n minus 2. देखो भाई, I 0 से start हुआ है, and I will take values till n minus 2. But how many different values are we talking about? 1, 2, 3, 4, n minus 2 plus 1. ये 0 भी तो है ना भाई. So total number of times the loop run is n minus 1. I will take values from 0 till n minus 2. But how many values are these? These are n minus 1 different values. भाई जब मैं तुम्हें बोलता हूँ I takes value from 0 till 9. So these are 10 different values na. From 1 till 9 are 9 values and 0 is also a value. So 10 different values that I is taking. That is what I am trying to say. Okay. Now, अगर I equal to 1 होता ना, then I would have done here less than equal to n minus 1. Because I want this loop to run for n minus 1 times. Okay. Now, what are we doing in the logic? what are we doing in the logic? What are we doing in the logic? I start J from 0. I start comparing elements from starting. Okay. And I compare ARR of J with ARR of J plus 1. So let us start running. Let us start running, right? So I will start my pointer J for int. J will start from 0. Okay. And I don't know where should J go till, but I know that in the first pass, okay, in the first pass that was getting performed, till where is J coming? Till where? Till index number n minus 2. Do you agree? Till index number n minus 2 inclusive. So if I write here n minus 1, does this work fine? Does this work fine, guys? When I is equal to 0, I am talking of the 0th pass, right? So J will start from 0 and it will go all the way till index number n minus 2. And what I will do? I will compare. Boss, if what I will check? No, J doesn't start from I plus 1. Harshvardhan, if you see, you are now defying the logic, right? Agar aap logic dekho, every time we start comparison from the starting itself, right? In the second pass also, I started comparison from the start. In the third pass also, I started comparing from the start. So J is always starting from index 0 only. Okay. So J starts from index 0. J will go till, let us say I do till n minus 2. J less than n minus 1 matlab J will come till index number n minus 2. Yes, Shubham, I will come to that. And I check if ARR of J, what I will compare with, if ARR of J is greater than ARR of J plus 1. Iska matlab kya hua? A bigger element is coming before a smaller element. So what will I do? I will simply swap. I will swap ARR of J with ARR of J plus 1. Do you all agree? This is the logic that we had discussed, right? And after swapping, J will move forward. That is J plus plus. Okay. And if you see that ARR of J is less than equal to ARR of J plus 1, you don't do a swapping. You simply move your J forward. Okay. I'm writing the pseudo code. I'm writing the pseudo code. Okay. Now, guys, I ask you one thing. When the value of I was equal to 0, J went all the way till n minus 2. Now, when the value of I will become 1, that is, I am talking of the second pass. So J should come till one location behind. Do you agree? Bhaiya dekho, for I equal to 0, J was coming all the way till index number n minus 2. Okay. For I equal to 1, now J should come all the way till index number n minus 3. Do you agree? So can I say J less than n minus 1 minus I? So when the value of I will be 0, J will come till index number n minus 2. Then when the value of I will become 1, J will come till index number n minus 3. And likewise, we will keep on adjusting till where should J move depending on the value of I. Is this making sense, guys? Achha, some people had doubt that J will start from I. Why will J start from I, guys? Try to understand. Look at the logic. Here, this is I equal to 0th pass. This is the 0th pass. So where did J start from? J started from index 0 and we started doing comparisons. Okay. Now, when you came to I equal to 1, the second pass, J starts again from index 0 only. See, I started comparing from the starting only. Okay. Starting only. So first of all, सब लोग agree करते हो क्या कि J will start from index 0 only? ये पहले बताओ. See, the outer loop is running for n minus 1 times. And every time the loop runs, we will perform one pass of bubble sort. Okay. So this I is telling me what is the pass number. Okay. So for I equal to 0, J starts from index 0. ध्यान से देखो. J starts from index 0. And where will J come till? N minus 1 minus I. So I is 0. So J will come till n minus 1. That is, J comes till index number n minus 2. And this is what we wanted. No, Sams. J cannot be from 1. I am comparing ARR of J with ARR of J plus 1. So J will start at index 0 only na. Okay. Bhai, soch ke batao, guys. Tell me. When I is equal to 0, J should be coming till index number n minus 2. Do you agree? J should be coming till index number n minus 2. So if I write here J less than n minus 1 minus I, what is the value of I? 0. So J less than n minus 1. So does it make sure that J is coming till index number n minus 2? Soch ke batao. Yes. Now when I go to the second pass, the value of I is 1. Okay. So what will be n minus 1 minus I? It will evaluate to n minus 2. So when I say j less than n minus 2, it will automatically take care that j comes only till index number n minus 3. So when I do a minus I now, with every increasing pass, j will go one location back. Are you getting this? देखो ना, for I equal to 0, j was coming till here. Okay. Now when I equal to 1, j is coming till one location back. Again, when the value of I equal to 2, j will come one location back. समझ आ रहा है? Again, I'll repeat it once again. See, look at I equal to 0 pass. Okay. I am drawing a blank array for your understanding. What were we doing in I equal to 0 pass? I started j from 0. I started j from index 0. Okay. I did this comparison, j move forward. 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 Okay. So this was the last location till j was coming. Do you all agree? For I equal to 0 pass, you did this comparison, this comparison, this comparison, and this comparison. Do you all agree that j is coming till here? Because I am comparing j with j plus 1. So for I equal to 0, can I tell you that this expression will satisfy well? j less than n minus 1 minus I. जब I का value 0 put करोगे ना, तो you are telling that j should be less than n minus 1. That is, j should come till index number n minus 2. And that is what is happening. सही है? Now, come to I equal to 1. Come to I equal to 1 part. Come to I equal to 1. We are talking of the second pass. Okay. We are talking of the second pass. कितना element लिए थे? 1, 2, 3, 4, 5. Right? Now, what will happen in the second pass, guys? J will again start from index 0. ध्यान से सुनो. Okay. J will again start from index 0. I compare. I do this comparison. Okay. I do this comparison. Okay. I do this comparison. Okay. So j will come only till here. Do you agree? J will come only till here. Yes. See, Gaurav, you are trying to defy the logic. Sorry, Aniket, ji plus 1 से कैसे start होगा? When in every pass I am starting to compare elements from the starting, then how can you start j from I plus 1? How? कैसे कर सकते हो? अगर मैं starting से compare कर रहा हूँ, what happened? I think I just lost my ink. Oh no, we came forward. Just give me 1 second. Okay. Just give me 1 second. So in I equal to 1, that is the second pass, right? J is coming till here. See, for I equal to 0, okay, J was coming till here. For I equal to 1, J is coming one location till the back. So what have I done? J less than n minus 1 minus I. Ki boss, now the value of I is 1. So J will be less than n minus 2. I का value 1 put करो, J less than n minus 2. Okay. So J less than n minus 2 means J will come till index number n minus 3. Here. That is what we wanted, right? See, even if you don't put a minus I here now, you don't have a problem. Ultimately, you will be doing more number of comparisons. By writing a minus I am making sure that J is coming till the correct location. Okay. How many of you have understood the algorithm? कितने लोगों को समझ में आया है? How many of you are clear with what is going on? Okay. See, for int I equal to 0, I'll repeat once again the outer loop. For int I equal to 0, I less than n minus 1, I plus plus. So the outer loop will run for n minus 1 times. And every time the loop runs, one pass of bubble sort will be performed. Now, what are you doing in bubble sort? You start j from 0 because always we start comparing elements from the start. So we start j from 0. Now, till where should j come? Till where should j come? J, मैं बोलता हूँ, forget about this minus I. Forget about this minus I for the finding. If I say j less than n minus 1, if I say j less than n minus 1, okay, then till where will j come? J will come till the second last element. Why did j start from 0? Okay, Vikas, देखो, मैं start कर रहा हूँ comparison from the starting of the array ना. So what is the starting index? 0 only ना. So j will start from 0. I compare ARR of j with j plus 1. Okay. So I compare, swap. So if I say j less than n minus 1, till where will j come? J will come till index number n minus 2, and you will do this comparison. Okay. But what I am telling is, ki boss, even if you make j come till here every time, that is fine. But as the value of I is increasing now, j should come one location to the back. For I equal to 0, j was coming till here. I had ensured. For I equal to 1, j will come one position back. That is why I have done a minus I. कि जैसे जैसे I का value बढ़े, j should come one location to the back. If j is going till the end, no problem. But you are doing unnecessary comparisons. Okay. Why I less than n minus 1? I less than n minus 1 because I want to perform n minus 1 passes. Even if you do I less than n, that is fine. But I need only n minus 1 passes. If you do I less than n, you are performing n passes. Okay. But your array gets sorted after n minus 1 passes only. Okay. Now, let me go to the visualizer. अच्छा, visualizer के पहले, if I look at this code, can you guess it is big O of n square? Forget the logic. Now let's do the analysis first, right? What is the if condition? You are comparing adjacent elements, ARR of j with ARR of j plus 1, right? And if the ARR of j is greater than j plus 1, so you will do a swapping. Okay. See, for j starting from 0, and let's say j is coming till n minus 1 minus I, j plus plus. Okay. And you are doing something inside, I don't care. What is this? How many operations are performed? Let us compute fundamentally. For I equal to 0, how many times does the inner loop run? Can anybody help me? For I equal to 0, how many times the inner loop run? ऐसे समझो guys, देखो. For I equal to 0, the inner loop will run for n minus 1 times. And you will do n minus 1 comparisons. And that is what we were doing in bubble sort. Then the value of I will become 1. For I equal to 1, how many times the loop will run? The loop will run for n minus 2 times. So you will perform n minus 2 comparisons. अब समझ में आ रहा है क्यों minus I किया हूं? For I equal to 2, the loop will run for n minus 3 times. You will do n minus 3 comparisons. Okay. Likewise, I will take values till n minus kitna? 2. And for I equal to n minus 2, how many times will the inner loop run? The inner loop will run only once. So if I see how many times this operation has been performed, it is nothing but 1 plus 2 plus 3 plus 4 till n minus 1, which is nothing but n into n minus 1 by 2. So the runtime complexity, the worst case of bubble sort is big O of n into n minus 1 by 2, or you can say big O of n square time complexity. Do you all agree? Yes? Okay. And what is the space complexity? What is the space complexity, guys? Have we used anything extra? Have we used anything extra? No, we haven't used any extra space. We are just doing swappings. We haven't used any extra space. So the space complexity is big O of 1. Constant space. Constant space. Okay. Why n square? Dekho, boss, you have two nested loops, right? You have two nested loops. See, this inner loop performs a pass of bubble sort. And you have to perform this pass n minus 1 times. So definitely it's n square, right? Okay. Let us now come to the visualization that will give me. See, the array is given to you as an input, right? You are not making a new array for yourself. Okay. Space is constant space, right? You are constant space. You have not created any new data structure or any new array, right? You have just used normal primitive variables which don't contribute to space. Okay. If you do j is equal to I plus 1, your algorithm will be wrong and you will never get the answer. In every pass, you start comparing from the starting only, na? That is why we do j equal to 0. अच्छा, एक जन ने क्या पूछा, एक second. Can we do like I equal to 1, I less than equal to n, I plus plus, j equal to 0, j less than. Yes, you can do, but then you see you are basically running n passes, and in every pass you are making j go till the end. Okay. So that is, you are doing extra work. You will get correct answer, but you are doing extra work. Okay. Array will not count in the space complexity. देखो, मैं क्या बोल रहा हूँ, आपको array को sort करना है. See, I have given you a plate. Think of it like this. I have given you a plate and I want you to do decoration on it. Okay, so I will not count this plate as extra space, right? मैं इसी पे ड्राइंग कर रहा हूँ, एक्स्ट्रा स्पेस कुछ थोड़ी लिया, आपने जो प्लेट दिया मैंने उसी पे ड्राइंग किया. ओके, नाउ let us come to the visualization part of bubble sort. This will help you to understand very well. Okay, so this is the array given to us, right? Okay, this is the array given to us. देखो भाई समझ आ रहा है the elements? Are you able to understand the elements here? Yes. अब यहाँ पे ध्यान देना guys. This will help you to understand very beautifully what bubble sort does. Okay. Now let's start. What we will do, guys? We start comparing elements from the starting. Okay. So I start. See, for each pass, ध्यान से पढ़ो. For each pass, we will move left to right, swapping adjacent elements as needed. Each pass moves the next largest elements to its final position. That will be shown in green. चलो आगे बढ़ते हैं, देखते हैं. ठीक है. Starting pass number 0. ध्यान से देखना guys. Please observe very well. Starting pass number 0. Okay. Now what happens? See, it starts comparing. I will start comparing adjacent elements. अच्छा, are you able to visualize the color difference? Color difference समझ में आ रहा है क्या तुम लोग को स्क्रीन पे देख के? Yes. So I am comparing adjacent elements. I am comparing 838 and 449. 838 is greater. So what should happen, guys? I should swap. See what is happening. Sorry. देखो, it is see, wait. I am comparing 838 and 449. 838 is greater. See, swap कर दिया adjacent element को. ठीक है. Now what will we do? We will compare 838 with 704. Next we will compare. Okay, what will happen, guys? Can you help me? Can you help me? What will happen? 838 is greater. So again, you will see a swapping happens. Okay. Then we will compare 838 with 929. Okay. What will happen, guys? 838 is lesser than 929. No swapping happens and J just moves forward. Okay. So what is the next comparison that we do? ARR of J, that is 929 with 381. I do a comparison. 929 is greater. I do a swapping. Okay. Then what will we compare? We will compare 929 with 582. Greater. Again do a swapping. Next we will compare 929 with 565. Greater. Do a swapping. See guys, now my J is on the largest element, right? And you will see that 929 goes to the right and it will settle at its correct position. Again, you compare 929 with 395, greater, do a swapping. And now I say that pass number 0 is done, or my first pass has been done. And see, this is marked in green. That is the heaviest element is now at its correct position. Did you guys understand what is happening in the pass? This is a very beautiful visualization. Okay, I don't think you will get any better visualizer than this. Okay. Let us again look at the second pass. Okay. Now, guys, try to understand. I equal to 1 hai. Okay. You are starting from pass number 1. But do you start comparing from 704? Do you start comparing 704 or 838? Or do you compare 449 with 704 first? सोच के बताओ. जो लोग बोल रहे थे, can I start J from I? No, you cannot. I am starting pass number 1, right? But again, you will start comparing from the starting itself. देख लेते हैं. See? For each element, again I start from the starting. I compare 449 with 704. Is there any swap happen? Is there any swap happen? No. Move forward. Next I compare 704 with 838. Any swap? Do you think any swap? No swap. Move forward. I compare 838 with 381. Now see guys, now my J is pointing to the heaviest element. ARR of J is heaviest. अब तुम लोग देखोगे, this element will be pushed extreme to the back. Now see. 838, 381, greater, do a swapping. Next, I compare 838 with 582, greater, do a swapping. Next, again, you will do a comparison, swapping. Again, you will do a comparison, swapping. Now, what I am telling you, do you need to compare 838 with 929? Do you need to compare? No. So, J should be coming till index number 5 only. Once you compare index number 5 and index number 6 and do a swapping, your job is done. Right? See? It will say done this pass. Now the two heaviest elements are at their correct position. That is why I was telling you don't want J always to come till the end. Okay. How number change from 838? देखो ना, देखो एक और follow करो. ठीक है. Next again you start. See, you start 449 compare with 704. No change. Move forward. 704 with 381. Yes. Now see guys, J is equal to 1, right? So ARR of 1 is greater than ARR of 2. So you will do a swapping. Now you will compare ARR of 2 with ARR of 3. Again, you will see it's greater, swapping. Again, you will compare, swapping. Okay. Again, you will compare ARR of 4 with 5. You will do a swapping. Okay. Now tell me, guys, once you had compared ARR of 4 with ARR of 5 and you did a swapping, do I need to compare index 5 and 6 elements? No. That is what I'm telling. J will keep on moving one space to the back. Now see, the 3 elements, heaviest elements, are sorted at the end of third pass. अब मैं थोड़ा जल्दी जल्दी लेके जाऊंगा, right? Now let us have a look at pass number 3, or basically pass number 4, right? They had started from pass number 0. I compare 449 and 381, swap. Compare 449 and 582, no change, move forward. Compare 582 and 565, swap. 582 with 395. See, this is the last comparison that will happen, right? See, this is the last comparison. Now, guys, try to understand. Try to understand. Every time you are starting from index 0, right? And what is this pass? This is my I is equal to 3. See? This was I equal to 0 pass, 1 pass, 2 pass. This is pass number I equal to 3. Now, N is equal to 7. So can I say J should be coming till index number 3 only? This is the last comparison that you will be doing. So when I say J less than N minus 1 minus I, okay, what is N? 7. 7 minus 1 is 6. 6 minus 3 is 4. So I am telling J less than 4. So is it not simulating that J should be coming till index 3 only? This should be the last comparison that we do. Dekh lo. That is what we are achieving by N minus 1 minus I. Okay. Now, this is the last comparison that we will do for this pass. 582 and 395. Yes, do a swapping. Done for this pass. This pass has been done. And 582 is at its correct position. Okay. Next, we will again do one pass. Ab main to jaldi dikha raha hu. Start comparing from the starting. No swap. Okay. 449, 565. No swap. 565, 395. This is the last comparison. Last comparison, right? Okay. So what will happen? Do a swap. Ho gaya. Hai na? Next, what will happen? See, this is correct. Now again, I start by pass number 5. J starts from index number 0. I do a comparison of 381 and 449. No swap. Do a comparison of 449 and 395. Now see, guys, try to understand. What is this pass number? फिर से बता रहा हूँ. What is this pass number? For pass number 0, you settled the heaviest element. Pass number 1, pass number 2, pass number 3, pass number 4. So this is pass number I equal to 5. Okay. And what is N? N is equal to 7. So what is N minus I minus 1? 7 minus 5 is 2. 2 minus 1 is 1. Okay. So I am telling J less than 1. No, I think we have missed out something. I equal to 0. I equal to 1. I equal to 2. I equal to 3. I equal to 4. I equal to 5. Okay. I equal to 5 hai na ye? 1 second. Yeah, N is equal to 8. Sorry. N is equal to 8, right? So N is equal to 8. There are 8 elements, right? And this is pass number I equal to 5. So what is N minus I minus 1? 8 minus 5 is 3. 3 minus 1 is 2. So J should be less than 2. That is, J should be coming till index number 1. Okay. So this is the last comparison that you do. So I hope this is becoming clear, right? So now you see, swap, done. 449 पे आ गया अपने correct location पे. Now you again do the last pass. I compare 381 with 395. No changes. No change. 395 is at its correct location. When now all these numbers are at their correct location, can I not say this is the element at the 0th index is also at its correct location? This is hacker earth. Okay. Done sorting. See. Now I will introduce the poll. So if you do not do a minus sign, see, time complexity doesn't change. It remains n square only. But the number of operations will reduce. Okay. So I'll make this poll go live. Okay. And I had to copy the link first, which I forgot. But yeah, guys, now I'll ask you guys, how many of you are clear with the concept of bubble sort? I think this is the best visualizer that is available. Poll pe vote kar do, so I get an understanding, right? How many are clear? Sharing the link, right? I want some responses, guys. Otherwise, I'll not be able to move further, right? Stop the chat for a second. Okay. Let's stop the chat. Band. Please, guys, do the polling. We have 500 people in the class, right? I'll expect at least 400 to go and give a response, right? Please send a response so that I'm able to figure out how many of you are clear, right? जो बाद बाकी जो 10-15% if you are not clear, right? If you now try to do a dry run, you will understand what is happening in the code. Okay. फटफट से पोल कर दो guys, फटफट से. Okay. So I think most of you are clear, right? So the 9-10% people who are still not clear, right? I will request you all to do a dry run of bubble sort on a piece of pen and paper, looking at the code. Try to do a dry run on a piece of pen and paper, okay, looking at the code. And then you will understand more clearly what is happening with bubble sort. And I will request the 90% of the folks who are clear, please help the remaining 10% of the folks and make sure that, yes, your peers are also understanding, okay? So I will not spend more time on bubble sort, but I'll expect people who are clear, please help out the folks who are not clear. And for the folks who are not clear, first of all, try to do a dry run on a piece of pen and paper, and then you will understand it more better. जब खुद से लिखोगे ना, तो ज़्यादा अच्छे से दिमाग में घुसेगा. Okay? Cool. Let me start the chat once again. Cool, guys. Thank you. So I think this gives me the confidence to move further. Okay. Okay. So let us write the code. Let us write the code for bubble sort. लिखे code. So till now, what have been my conclusions? If I want to summarize the key metrics, okay, if I want to summarize the key metrics of bubble sort, can I say like this? Bubble sort, मैं key metrics लिख रहा हूँ. It will require n-1 passes. See if you understand all the parts, right? Then it will take n into n-1/2 comparisons. Okay. The number of swaps is big O of n into n-1/2. This is the worst case number of swaps. Okay, this is the worst case number of swaps. And when does the swaps and comparison become equal? When the array is sorted in descending order. Okay. And the last thing is, what is the time complexity? Big O of n square. Okay, this is the time complexity. And what is the space complexity? Big O of 1. This is the space complexity. Okay, clear? Now let us try to write a code. Acha guys, this code sorts in ascending order. Can you try to write a code which sorts in descending order? क्या change करोगे code में? Can anybody help me? What condition? Only the if condition will change, right? Just the if logic will change. Correct. वैसे ही मैं बोला था. Sorting is simple. It's simple, right? If you understand it well now, it's very good. It's very good, right? It's very good. Okay. So let us come to the. Okay. Now we'll try to implement bubble sort. Okay. Now quickly, guys, can you help me with bubble sort? Or do you want me to make a function for it? Or what? Or do you want me to write? Yes, let's write a function for it. Better, right? So what I'm saying is public static void. The return type is void because, you know, I'm changing the things in the array only. So I'm not returning anything. Public static void. Let us call my function as bubble sort. Okay. It will receive an array of integers ARR. Okay. That's it, right? And I want to do a bubble sort. So chalo kya karte hain ab dekhte hain. So what I will first of all do? First of all, let us determine the size of the array ARR.length. Okay. So how many passes of bubble sort do I need? How many passes? n-1 passes. So let us write the outer loop. For int I equal to 0, I less than n-1, I plus plus. So this will ensure that the inner loop runs for n-1 times. Okay. So n-1 passes of bubble sort is performed, right? Now, what will we do? I am standing at the ith pass of bubble sort. Okay. Ith pass. Yes. This loop is just determining that, yes, you are performing n-1 passes of bubble sort. Okay. So when you are at the ith pass of bubble sort, what will we do? I start comparing. I start j from 0. And till where should j come to? See, if you do till n-2, that is not wrong. That is correct, right? J less than n-1, that is fine. But as the value of I increases, j should go one location behind. Utna j to niche tak ka jaane ka kaam nahi hai. So j less than n-1 minus I. Okay? J plus plus. And what will we do? We will check if we will check. If ARR of j is greater than ARR of j plus 1, that is, a greater element is occurring before a lighter element. So what I will have to do, I will swap ARR of j with ARR of j plus 1. And how do we swap? We take the help of a temporary variable. Int temp is equal to ARR of j. First, I store the contents of ARR of j. Then I say ARR of j is equal to ARR of j plus 1. Stored the contents of ARR of j plus 1 in ARR of j. Then ARR of j plus 1 is equal to temp. Yes, have I done the swapping? That's it. That's the code. Okay. So when this, see guys, try to understand. This loop will be running bubble sort once. This loop is running bubble sort once. How many times you need to run this loop? You need to run this entire thing. You need to run this entire block n minus 1 times. That is why I have enclosed it in a outer for loop. Okay. Yes, making sense? How does the swapping run? See, I want, let's say, how do I swap the value of two variables, right? Again, a very basic thing. Let's say you have a variable a is equal to 5 and you have a variable b is equal to 10. Okay. This is one variable. This is the second variable. Now I want to swap their values. That is, I want that a is equal to 10 or b equal to 5 ho jaye. So if I do something like this, the boss a is equal to b. So what will happen? The value of b will be assigned in a. So this 5 will get overwritten and 10 will come here. Do you agree? Yes. But in the process, what has happened? You lost the original value of a. Do you agree? When you do a is equal to b, you will lose the original value that a was storing. So what do we do is, when I want to swap two variables, first of all, what do? I take the backup in a temporary variable. Int temp is equal to a. So temp will store the same contents as variable a. Okay? Then what do? Then I write the line a is equal to b. So I will take the value of b and write it in a. So now a has got a value of 10. Now I want that b should contain the value 5. So what I will do? I will next do b is equal to temp. Okay. So the value of temp will be taken and this will be stored in b. Okay. Is this making sense? Yes. Okay, now. So via the third temporary variable, we are swapping the two numbers, right? Okay. Line number 23. That's it. Now it's swapping. I take the backup of ARR of j in a temporary variable. I write the contents of ARR of j plus 1 in ARR of j, and then I write the contents of this temp in ARR of j plus 1. Okay. Okay. No, I don't think there is predefined function for swapping. For sorting, there is. We will talk about it later. Okay. But let us. So can I say, guys, after this thing, the array will become sorted? Can I say this? Yes. Okay. And see, guys, there can be multiple algorithms of bubble sort, right? There can be different ways in which you implement bubble sort, right? I am just giving you one of the techniques which are simple to understand. What is your question? Why did you not? I initialized now. How to pass the value of ARR of j? Why do you want to pass the value of ARR of j as a parameter? I am passing the entire array now. This function will take the array and will sort it. That's it. Temp नहीं समझ में आया. अच्छा guys, try to understand temp once again. देखो, मैं क्या बोल रहा हूँ? Let us say I want to swap the contents of two variables. Okay, a is equal to 5 and b is equal to 10. So how do I swap their values? I first of all take a variable temp is equal to a. So temp will store the value 5. Then what do? Then I say, see, first of all, I do temp is equal to a. Then what I do? A is equal to b. So what I will do? I write the contents of b in variable a. Kiya to initialize temp. In temp is equal to ARR of j. What is this? Okay. Now what will happen? Try to understand. Now I want to write the contents of a in b. And where are the contents of b? In temp. So I will say b is equal to temp. So what will happen? The 5 contents of temp will be taken and it will be written in b. So I have changed the values of a and b, right? Now a is 10 and b is 5. Okay. Okay, guys. So we have done a swapping. See, if you want to do an I less than equal to n minus 1, you will have to start I from 1. Ultimately, मैं क्या चाहता हूँ, guys, try to understand. This entire block, right? This is a pass of bubble sort. अरे हाँ भाई, कुछ भी ले सकते हो. Yes, कुछ भी. Whatever variable, right? this entire block, right? This entire block is performing a pass of bubble sort. How many passes you want to perform? N minus 1 passes. So that is why I am running this loop for n minus 1 times. Yeah, I0, 1, 2, 3, 4 till n minus 2. So this will run for n minus 1 times. And every time I enter inside this loop, a pass of bubble sort will be performed. Okay. So the return type is void. So you can just write return. You don't care. Okay. Now, how will I do it from the main method? Let us say I make an array for our simple understanding. I am just hard coding stuff. Okay. And I want to sort it. So how will I do it? How will I do it? How will I do it? Can anybody tell? I will call bubble sort. I will call bubble sort. Okay. Pass it the array ARR. Done. Now, done. Now I just want to print the array. Okay. So let us print the array using a for loop. Okay, guys. Let's try to run it. See, guys, is it working? Is it working fine? Boss, J last तक कभी जा ही नहीं रही, यही तो मैं बता रहा हूँ. Someone had asked that J and J plus 1 will give an error when J is at end. But till where is J coming? J is coming till here. When the value of I is 0, J is coming till index number n minus 2. So you can compare J with J plus 1, right? Okay. So this is the bubble sort technique. Now try n minus 2. No, n minus 2 will not work, right? If you give your n minus 2, you are not performing n minus 1 passes of bubble sort, right? Yes, we are not returning any value because I have made the changes in the array itself, right? Dekho na, I am doing the swapping in the array itself na. So why do I need to return anything? I already have the reference of the array in the main method, right? ठीक है. Line number 14. Public अभी लिखना है अपने लोग को. What is line number 14? Line number 14 is very simple. It is just printing the array, man. Okay, cool. So now I want to discuss two other important things and then we'll again go for a poll, right? Why is the return type void? The return type is void because I am making changes in the array in place. Okay, मैं array में ही changes कर रहा हूँ, ठीक है? So why do I want to return anything? You already have access of the array in the main method, right? Okay, I'll come to two more concepts first because before I look at the questions, right? Okay, cool. Can't we make, if you want, you can just have the code in the main method. That is also fine. I just wrote functions so that you are able to understand more clearly. We are using another loop for printing values. Big O of n time होगा उसका क्या दिक्कत है? If you are printing also na, n square plus n is big O of n only. And please focus more on the algorithm. Descending order बताओ नहीं, सोचो. Descending order करो खुद से. Okay. Cool. Okay. Now I want to discuss two other terms related with sorting, right? One is stability and the other is adaptiveness. These two terms we want to discuss and then we can call it a day. Okay. So what is a stable algorithm? फटफट बताता हूं. What is a stable sorting algorithm, right? So let's say, focus here, guys, focus here. Let's say that you have an array, right? Okay. And you have same elements in the array. ठीक है, 2 बार 8 आ रहा है, ठीक है. But somehow I have labeled these 8 कि this is 8 star and this is 8. ठीक है, मैंने color कर दिया, ठीक है, कि this 8. See, I'm just differentiating between the two 8s, right? See, this 8 is red in color and marked with a star, and this 8 is the same yellow color. Okay. So in the original array, 8 star is occurring before 8. Okay. Now let's say you sort the array. Okay, you sort the array. Okay. So after sorting, okay, if the relative ordering of the two 8s are maintained, देखो, original array में 8 star was appearing before 8. When you sort the array, still 8 star is appearing before 8, right? So what I am saying, if the relative ordering of the same elements is not disturbed, Okay. If the relative ordering of the same elements is not disturbed, then we say that the sorting is stable. That is a stable sorting algorithm. But let's say that you sorted the array and I got the output like this. Okay. Umar Mukhtar, are you clear with the basic logic at this point of time? Function कुछ नहीं किया, सिर्फ function declare करके call किया, right? If you are clear with the basic bubble sort logic, let's focus on that at the point, right? When I solve some questions on functions, I'll try to make you guys understand more, right? Okay. So now see guys, my original array, देखो, in my original array, you had 8 star before 8. And when you sorted the array, na, 8 star comes after 8. So what is happening? The relative ordering of the two 8s have changed. Do you agree? In the original array, the 8 with a star occurred before the normal 8. But after sorting, the 8 with a star is occurring after the normal 8. So the relative ordering of the same elements have changed. And this sorting algorithm, which disturbs the relative ordering of the same elements, this we call it as unstable. So what is stability? Let's say you are given a sorting algorithm, and if the relative ordering of the same elements are not disturbed, then we say that it is a stable sorting algorithm. But if the relative ordering of the same elements are disturbed, they get disturbed, then we say that it is an unstable sorting algorithm. Is everyone clear with the meaning of stability? Where can it find its application? Let us take an example. Let's say I tell you, you have the name of students, okay, and the time at which they entered the class, okay. So Mohit entered at 9 a.m. Let us say 9 a.m. Okay. Then let's say Ram entered at 9:05. Okay. Let's say, Shyam entered at 9:05. Okay. Now let's say Adarsh entered at let's say 9:10. Okay. And let's say there is another Shyam that has entered at 9:15. These two Shyam are different, right? So this is sorted by time. Just giving you a practical example. This is sorted by time, right? Now I tell you, hey, can you sort it by names? Can you sort the array by names? Okay. And if two people have the same name, if two people have the same name, then you should sort it by the timing. You should sort it by the timing. Dekho? So what is happening? If two people are having the same name, I don't want to disturb their relative orderings. Let's say this is a fat Shyam, okay, and this is a thin Shyam, just for your understanding, right? So I want to sort in alphabetical order. So let us sort. So Adarsh will come at the first, 9:10. Now I'm not understanding of time, right? Then A ke baad kya aayega? M, L, M, N, M. So Mohit comes. Mohit, he was entered at 9. Then Ram comes. And then you have two Shyams, right? But now, if I want, ki boss, if two people have the same name, I want to access the person who had arrived earlier. So if my algorithm is stable, then the ordering of the two Shyams will not be different. First, you will get the fat Shyam followed by the thin Shyam, right? But if the algorithm is not stable, then you will disturb the relative ordering of the two Shyams, right? So if the relative ordering of the same elements get disturbed, you call it as an unstable sorting algorithm. And if the relative orderings remain the same, then it is a stable sorting algorithm. Now, given the concept of stability, I have one question to you all. Okay. I have one question to you all. Is bubble sort stable or not? Is bubble sort stable or not? Look at our algorithm. Is bubble sort stable or not? When are we swapping? Guys? When we see that one element is greater than the next element. Now try to understand. I will take an example, right? Let's say you have 6, 8 star, 5, 8, 10. Okay. So 8 star is appearing before 8. Now I just have to see whether these two 8s can get swapped anytime. I compare this 6 with 8 star, I don't do anything. I compare this 8 star with 5, I will swap, right? So how does my array look like? 6, 5, 8 star. Next, you will compare 8 star with 8. But now guys, try to understand. Whenever you compare the same elements, will you ever swap them? Is 8 greater than 8? No, it will never swap. So whenever you compare the same elements, you are not doing a swapping. So the relative ordering of the same elements will not get disturbed. Correct. Somebody has pointed correctly that if I put an equality sign here, then it becomes unstable. But the current implementation of bubble sort is stable because whenever you compare the same elements, you will never swap them. So the relative ordering will never be disturbed. So does everyone understand bubble sort is stable? Yes? क्यों बबल सॉर्ट स्टेबल हुआ? क्योंकि जब भी आप दो 8 या दो सेम एलिमेंट्स को कंपेयर करोगे ना, you will never swap them. And when you never swap them, the relative orderings will never be changed, right? So bubble sort, as we have discussed, that is a stable sorting algorithm. Okay, so everyone is clear with this. The next term that I want to discuss, the last term that I want to discuss is adaptiveness. These are traits of any sorting algorithm, right? So bubble sort is, if you use greater than, then it is stable. If you use greater than equal to, it becomes unstable. Okay. भाई कोई लॉजिक लिख ही सकता है ना, greater than equal to में swap कर दो. अरे अगर same भी है, if you are swapping also, arrays remain sorting only, right? But the relative position of the same elements will change. Okay. Now let us come to what is adaptiveness, right? Now let's say you have a sorting algorithm. Okay. Now you can have different types of inputs. Okay. One will be a very bad input. Let us say I am sorting in ascending order. I want to sort in ascending order. What will be the worst case input where you have to do the maximum work technically, theoretically? If you give your array in descending order, you will have to do the most work. And logically, when will you expect to do the least amount of work? If I already give an array that is sorted, do you agree? Agar मैं already sorted do, so you will expect that it should do less amount of work. Okay. So what is adaptive is, I call an algorithm adaptive if when we give it a sorted input now, the time complexity reduces. For bubble sort, we saw that the worst case time complexity is big O of n square, right? Now I want to understand, boss, is my algorithm adaptive? Can it adapt itself to the input? Is it intelligent enough to adapt itself to the input? Ki boss, if I give a sorted input, what is the time that bubble sort will take? Can anybody help me? I will say that my algorithm is adaptive when for a sorted input, it consumes less amount of time. But what will happen for the bubble sort that we have written? Do you think it will consume less time? No. For a sorted input also, you will take big O of n square time. Go and check the code. Even if you get a sorted array, right? What will you do? Let's see. You compare 1 with 2, nothing. You compare 2 with 3, nothing. You compare 3 with 4, nothing. Pass 1 done. Then you go to the second pass, right? You compare 1 with 2, you compare 2 with 3, and then. So you understand that even if you give a sorted input, bubble sort will take big O of n square time. So currently bubble sort is not adaptive. Do you all agree with me? Currently bubble sort is not adaptive because still it is taking n square comparisons. Yeah, 0 swaps, but n square comparisons. So the time complexity is still n square even for a sorted input, right? Now the question comes, can we make it adaptive? And the answer is yes. I can make my bubble sort adaptive. Now I will give you a very interesting approach of making it adaptive. Now guys, try to understand. Now let us say that I am talking of a particular pass of bubble sort. Okay? I am talking of a particular pass of bubble sort. Okay. Okay. Let's say this is some random pass. Okay. Then let's say this is the second pass. Okay. So the heaviest element is already at the bottom. Okay. And I am performing the second pass of bubble sort. Okay. Now let's see what happens. I compare 8 with 10. Do you need to swap? No. I compare 10 with 15. Do you need to swap? No. I compare 15 with 25. Do you need to swap? No. So in this particular pass, I see that I need to do 0 swaps. Do you agree? No swaps. I didn't do any swap. और ध्यान से समझना guys. If you are not performing any swaps in a particular pass, इसका मतलब क्या हुआ? Every element is less than equal to its next element. Because if any element was greater than its next element, you would have performed the swap. But if every element is less than or equal to its next element, you will not perform a swap. And thus the array is sorted. So after a pass, You perform one pass and you see that if you have 0 swaps in that pass, your array is sorted. So you can break out, you can stop your bubble sort. So let's say I am intelligent enough, right? And I get a sorted array. Let's say I get a sorted array. Okay. I start comparing. Compare, no swap. Compare, no swap. Compare, no swap. Compare, no swap. Okay. After comparing n-1, after doing n-1 comparisons, I see that no swap has taken place. So I say that yes, the array has become sorted. I break and I say array is sorted. So for a sorted input, how much time complexity I consumed? What was the time complexity? You just did n-1 comparisons, right? So it is big O of n. Okay. So the interesting thing is, if in a particular pass you see 0 swaps, you can terminate your bubble sort at that point of time. And if you do that, you can make your bubble sort adaptive. When you feed an already sorted input, it will take big O of n time to tell you that yes, the array is already sorted. और इतना time तो लगेगा ही ना. Otherwise, if it doesn't even take a big O of n time, how will it determine if the array is sorted or not? आपको हर element पे जाके check तो करना पड़ेगा ना, right? Now, the interesting part comes, how do you make it adaptive? See, what I'm trying to say, adaptive means that when you give a sorted input, it should take less amount of time. It should take less amount of time, right? So what I want you guys to understand is, if in a particular pass, मैं क्या कर रहा हूँ? I check this element with the next element. Less than equal to, no. Then again I do a comparison of these two, no swap. Again I do a comparison of these two, no swap. So if in a particular pass, you see that you have no swaps, हो गया array sorted. Okay. So if you give a sorted input, how much time you will take? You check this, check this, check this, check this. No swaps, job done. So for a sorted input, you will take big O of n time. So if I am able to make my bubble sort adaptive, the best case runtime of bubble sort will be big O of n. Do you agree? The best case runtime of bubble sort is big O of n. The best case runtime of bubble sort is big O of n if it is adaptive. If it is adaptive, right? And when will this best case arise? When you give an already sorted input. Now let us try to understand, how do I make bubble sort adaptive, right? Now, anybody, do you have any ideas? No. You cannot break with the if condition. No. Try to understand, guys. You have to iterate all the way. See, right? See, जो if condition का बोला ना, वो गलत हो गया. क्यों? Try to understand. I compare 5 with 8. Okay. 5 is not greater than 8. Should I break? No, I can't break, right? I have to iterate through the entire array, na? Because 8 is greater than 7. There will be a swap. Okay. So what I will do? I will use a flag variable. Let me go to the code and give you an idea. Now, what do we do is, see, here, what I will do is, see, before starting the operations for a pass, before starting the operations for a given pass, what I will do, I make a Boolean flag. I make a flag and I make it as, let's say, false. I initialize the flag as false. Now what will I do is, this for loop jaise hi chalega na, you will be performing the pass. And once I enter inside this if block, can I say I have performed the swap? So the moment I enter inside the if block, I know that a swap has taken place. So I will set my flag equal to true. Okay. Now try to understand, guys. Once you are done with this entire pass, once you are done with the entire pass outside the for loop, you will check. Dekho boss, outside this for loop, can I say that I am done with the ith pass? Outside this for loop, can I say I am done with the ith pass? So I will check, boss, if my flag is equal to false, if my flag has remained false at the end, dekho, I had initialized, see guys, try to understand. At the starting of the ith pass, I made a flag, okay? For false, let me make it red colored. I had made my flag false, okay? And at the end of the pass, I have done the entire pass, the flag is still red. That means no swap took place. So my array has become sorted. So what will I do? I will simply break. You don't need to run more passes of bubble sort. You can simply break or you can simply return, whatever. If you are in a function, you can simply return. Otherwise, you can simply break. Okay. But if, let's say I had initialized my flag as, dekho, I am starting the ith pass, I make my flag as red. Okay. But if in the ith pass you get a swapping, then what am I doing? I am changing my flag to true. So my flag will become green. So after the end of the ith pass, you see that the flag is green. That means some swapping has taken place in the ith pass. So the array might not be sorted and you might need more passes. So I will not break. I will go to the next pass. Okay. Why not outside this for loop? Because guys, try to understand, right? Jab tum ek pass, you are at pass number 0, you will need a flag. You do pass number 0. For pass number 1, again you will need to initialize the flag now. That is why I am initializing the flag here. Okay. Making sense, guys? Correct. So now try to understand what happens. Now try to understand. If you have an array like this, right? Let's say 8, 1, 2, 3, 4. Okay. Let's say you have an array like this. Okay. Now let's see whether my bubble sort performance improves or not, right? So first of all, I will be equal to 0. That is, I am at my 0th pass. What will happen? J starts from 0. First of all, I will, make a flag that is red in color. That is false. Now what will happen? J starts from 0. I start. I compare error of J with J plus 1 greater. So what I will do? I will set my flag as true. Green kar diya, and I will swap. So what will happen? 1 comes here, 8 comes here. Then J plus plus hua, you compare 8 with 2. Okay. Again, there is a swap. The flag is already green. It will remain green. You do a swapping. So 2 comes here, 8 goes here. Then you will compare 8 with 3. Again a swap. 8 comes here, 3 goes here. Then you will compare 8 with 4. Again a swap. 8 goes here, 4 goes here. Now you are done with the pass number I equal to 0. Now what will happen? Now you come to pass number I equal to 1. ध्यान से देखो. Now you come to pass number I equal to 1. Now what will you do? For pass number I equal to 1, again I initialize the flag as red. Okay. See, even if you break, boss, you come here outside and you return simply. So kuch bhi kar lo. See, Kunal, again, your question is correct. Worst case, it is still big O of n square. Worst case is still big O of n square. Big O of n hua best case mein. If you give an already sorted input, na, this loop will run once and you will return. So you will not get an n square in the best case. But the worst case is still big O of n square, right? It's still big O of n square. You are correct. Okay. So now what will happen? I equal to 1. I again start iterating, through the array. Okay. I have initialized my flag and I start iterating. J starts from 0. 1, 2, no swapping. Okay. Yes, omega of n. Okay. Then you compare 2 with 3, no swapping. You compare 3 with 4, no swapping. Okay. Now, J will come till here only. So at the end of this I equal to 1th pass, there is no swapping. No swapping. Yeah, precisely it's n minus 1. Okay. So outside this, I see that the flag which was red, that has remained red. That is, there were no swapping. So my array has become sorted. So instead of doing more passes, I will break. And when I break, I come outside this for loop and I simply return. Okay. Making sense, guys? With the introduction of this flag, I have made my bubble sort adaptive. That is, if you give an already sorted input, you will get the output in big O of n time. So the return here is not necessary. I have just written it. Okay. How many of you are clear? Let's go back to the poll. कितने लोगों को समझ में आया कि this flag variable is helping you to improve the performance, right? मैं एक pass bubble sort का किया, and after that, if you see that there are no swapping, okay, if there is no swapping, right, then you know that the array has become sorted. So you will simply break. Okay. Clear but not crystal clear. Okay. So, 1 minute, guys. Okay. So I think I'll just make a question. What happens if we put flag outside? See, if you put flag outside, basically what you have to do is in the starting, okay, before you run bubble sort, right? Before you perform the ith pass of the bubble sort, you need to set the flag as true or false, right? So that is why what is important, right? If you declare flag outside, still you will have to initialize flag to false before you run it, right? Okay. Flag equal to true should be at line number 31. Let's see. Flag equal to 31. It should be inside this if block. It should be inside this if block. Because the moment you enter inside the if block, now there is a swapping. You can do a flag equal to true. Okay. Now, why have I written 80% is because the remaining 20% now, you will have to do a pen and paper run on your own. Then you will understand it more better, right? Or better usse samajh mein aayega. Okay. Let me share the link. I'll just wait for you guys. We are done with officially with bubble sort, right? Okay, you had the links. No, you can take flag equal to true also initially, but then your logic will change. Okay, your logic will change accordingly. Okay. Yeah. If you do more than one pass, it's not big O of n. But what I am telling is for the best case, if your input is already sorted now, you will get the answer in one pass. So that is big O of n, right? But definitely, if there are more than one passes, it's not big O of n, right? And this Slido is good, right? It gives me a very good idea of the understanding. Right? Okay. Okay, guys, थोड़ा आलस कम दिखाओ. Click on the link and please go and vote. Okay. And इसमें तो मजा आना चाहिए ना, जाके सिर्फ yes no करना है. Definitely more interesting than bubble sort for sure, right? Okay. So I'll take it's an 80-20 proposition at this point of time. So fairly good enough. I would say fairly good, right? So I'll request people to again help out each other and try to understand the concepts, right? I think I have covered it in the best possible way forward. बाद बाकी कोई भी doubt, so I am already always on Discord, right? You can DM me and अभी मैं थोड़ा coding channels भी देखना start किया हूँ, so I reply there also. Okay, but yeah, DM me. That's the best way to get a response. Okay, and yeah, I think that should be it about bubble sort, right? So if I want to revise or recollect bubble sort, worst case time complexity n square, worst case space complexity big O of 1. Is it adaptive? By default, not. Can it be made adaptive? Yes, with the help of a flag. When you make it adaptive, what is the best case runtime of bubble sort? Big O of n. What is the best case input? Ascending order. What is the worst case input? Descending order, right? How many comparisons are done? N into n minus 1 by 2. How many swaps are done? In the worst case, n into n minus 1 by 2. Is it stable? Yes, it is stable. Is everyone clear? Okay. Anyways, ठीक है guys. ठीक है. So I'll share the code with you all. Let's allow once again. See guys, now I will ask you all the remaining जो भी थोड़ा बहुत unclear है ना, एक बार pen paper खुद से लेके बैठो, right? Try to do a dry run, okay? And go to this visualizer. You will understand what is happening. This is a beautiful visualizer and this will help you a lot. Okay? Take the code, take this visualizer, try to sit with a piece of pen and paper. Because देखो, अगर सब कुछ आपको 100% एक बार में क्लास में क्लियर हो गया ना, then you will become complacent. It's good that you are not 100% clear in the class. But what I want is you get the overall picture, you understand what is happening, and then when you put it on a piece of pen and paper, you understand it even more better. Okay? Okay. I will share the link of the visualizer as well. अच्छा, is there anyone who can claim that he has understood 100%? ऐसा कोई है जो claim कर रहा है कि I have understood 100%? मैं कुछ पूछूंगा नहीं. I'm just asking. Is there anyone? Yes, there are people. There are people, right? 9900, that is fine. So please guys, try to help your folks. इसीलिए पूछा था. Please try to help the folks who are a little bit less clear. Because if you are 100% clear, I am pretty sure you will be able to convey it in a good manner, right? Okay. ठीक है. Question करेंगे. Not now. We will do question. Okay. I am disabling chats यार, बहुत chats आ रहे हैं. Sir, 1-to-1, please. I did not. ठीक है. Okay, Arpit. Just DM me on Discord. I'll set up a time with you for 1-to-1. Anybody who wants 1-to-1, just DM me on Discord, right? I'll give you time. Don't worry. Okay. So that was about bubble sort, right? Now we have discussed everything about bubble sort in detail with the visualization and everything. Now I will give you a homework. Right? So tomorrow we will do insertion and selection sort, right? So I will leave you guys with a hint, okay? with what is insertion sort. I will just give you a basic idea of insertion sort, and your job will be to think about insertion sort after you go from today's class and try to come up with a code yourself. Okay. I will expect you guys to try a code for insertion sort. I will give you the algorithm. Okay. And then it will be your job to ponder over it and come up with a code. Okay. So let us talk about insertion sort. Okay. हाँ मैं functions को भी कराऊंगा ठीक है. Insertion sort क्या होता है right? Now I am giving you a different method of sorting, right? Let's say 8. Okay. This is the array of integers. YouTube channel का क्या हुआ? It's been pushed back. I am not getting time. I want to start it very, very badly, but yeah, I think the problem is, I'm unable to get time. Okay. So there is 5 minutes left, right? So I'll take 5 to 10 minutes. बनाया नहीं है boss, अभी तक नहीं बनाया, right? I will take 10 minutes of your time, and I just want to give you a basic intuition behind insertion sort so that you can understand what is happening with insertion sort. Okay. Now what I'm telling you, you have an array of integers. And I ask you one thing, boss, just look at this line to the left. Look at the line to the left. Left mein dekho, left mein. This is, I claim that boss, to the left of this line, the array is already sorted. Do you agree? To the left of this big line that I have drawn, there is only one element, right? And if I have only one element, that is already sorted, right? See, to the left of this big line that I have drawn, you have only one element. So can I claim to the left of this line, the array is already sorted? क्या मैं बोल सकता हूँ, guys? To the left of the line, everything is sorted. To the right, it is not sorted, right? Now, what is my job? My idea will be insertion sort. Now, try to understand the name. I will pick the elements one by one. Okay. I will first of all pick this element, and then I will insert. Today it's only till 10. I will pick this element and I will insert this element in the already sorted portion on the left hand side. Okay. I will pick this element and I will insert the element on the already sorted portion on the left hand side. So what I will do? Acha guys, can you tell me how many insertions I will have to do? How many insertions I will have to do? If you have an array of n elements, can I say you have to insert this, 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 this? So do you all agree? If you have an array of n elements, you have to perform your insertion n-1 times. Yes, correct. Now let us see what happens in the insertion. Just giving you a basic overview. We'll discuss tomorrow in details, right? But I want you guys to think about it. ठीक है? थोड़ा खुद से भी सोचोगे ना तो दिमाग खुलेगा. How to think? Okay. Now, first of all, I come to this element. And I want to insert this element on the already sorted array on the left hand side. Already sorted part on the left hand side. So what do? I compare 5 with 8. Let's do like this. I compare 5 with 8. Okay. 5 is lesser than 8. Guys, what should I do? Can anybody help me? Logically, socho. Logically, 5 is lesser than 8. Correct, guys. Swap. Just swap. Okay. Swap kiya. Okay. So what happened? 5 came here, 8 came here. And then my pointer will come here. Should you compare anything else with 5? Do you have anything else to compare with 5? No. So I will say, boss, your one insertion has been done. You have successfully done one insertion. And after one insertion, how does my array look like? 5, 8, 5, 8, 7, 3, 2. So see guys, I say the array on the left hand part is now sorted. Do you agree guys? On the left hand part, the array is sorted. 5 and 8. Do you agree? Now what I want to do? Next, I will pick up this element. I pick up this element 7 and I want to insert it in the already sorted array on the left part. So what I will do? I start comparing. I compare 7 with 8. I compare 7 with its previous one. Okay. 7 is lesser than 8. So definitely 7 should come before 8. So what I will do? See, my pointer was here. Let's say this is J. I compare J with J minus 1, right? And because 7 is lesser than 8, I will swap. Let us swap. Okay. Then what I will do, guys? Now, once think of it like this. Once 8 has come here, 7 has come here. Now what I will do? I will compare this 7 with 5. I will next compare 7 with 5. Now, what do I see? 5 is less than equal to 7. Okay. So to the left of 7, you have already a smaller element. So can I stop here? Can I stop my iteration here? Yes, because 7 has been inserted at its correct position. So after this, can I claim after 2 insertions, You have an array of size 3 already sorted. देखो भाई, 5, 7, 8, 3, 2. Do you agree? I'll just take 1 more minute of your time. Yes, agree? Now what I will do? The next insertion is I will insert this element 3. Why is the name insertion sort? Because you pick an element and you insert the element on the already sorted part on the left hand side at its correct location. So what do? I first of all compare 3 with 8. I compare 3 with 8, right? What happens? 3 is lesser than 8, so I will swap. So how does my situation look? 3 is here, 8 is here, okay? Then I will compare 3 with 7. Okay, I compare 3 with 7. Again, 3 is smaller, do a swap. Okay, so next I compare 3 with 5. Again, 3 is smaller, do a swap. 3, 5, 7, 8. And now 3 has reached at the starting. There are no other further comparisons left. Okay, अब 3 को किसके साथ compare करोगे? कुछ है ही नहीं. So 3, 5, 7, 8. Done insertion of 3 at its correct location. See, I was inserting 3 and 3 was the smallest element. So 3 has come at its correct place. Okay. And now guys, see, after I have inserted till 3, okay, the last insertion is for 2. And you will see that 2 also iterates and makes its way all the way to the front. And after these n-1 insertions, your entire array will get sorted. Are you getting the basic idea? I guess this also n square. Correct. Correct. Basic idea mila kya aap log ko? What we are trying to do? Yes. So can you try to, get the algorithm in a piece of paper and try to code it up? Code करने का try करोगे? Yes? Okay, cool guys. So that should be it for today's class. Okay, we don't need a new array, right? We are doing swappings only, so we don't need new array. So I think I'll stop the recording here. So your homework, 2 homeworks you have, right?